Hello friends, welcome back to my video. So if you are still writing the TCP server using blocking sockets or select system call, you're not building a scalable system. Okay. So in production, like in routers and backend service, we use event-driven models. Okay. So today we will build a TCP echo server and that also not using the select system call. Instead, we will be using the libev library, and this libev library is internally using the epol for high performance for handling multiple clients as a production grade servers. They are using epols to handle thousands of connection of the clients. Okay, so this is the agenda. We will be talking about this TCP Echo Server using libev library and how to accept multiple clients, okay, to the same server without any lag, and how to handle the IO without threads. So in select system call, we are using threads to increase the performance, but here libev is a single loop uh, APIs that will be handling multiple clients at the same time, okay, without uh, having the performance degradation. Okay, so in this echo server, we will be using the TCP socket. Client will send the data, and the server send back to the same data. So this is an echo server. So whatever the client is sending, server will also respond with the same data. Okay, so the toast here, I already told you, like we will be using libev APIs and not the select system call, which handle very less connection, for example, 1024 and so on. But in libev, we are using a lot of connections, and we can handle multiple clients efficiently. Okay, so let's quickly start with our echo server. So I quickly jump to the main. Okay, so if you go into the main, if I start with this basic APIs, if you don't know how to create a TCP server, I will post a link to one of my old video where you will see how the TCP client server is communicating. But for this server, for this video as an echo server, we will be telling you about only the APIs. So here we have the TCP server first API, that is a socket system call, in which we are using a sock stream for TCP connection. Okay. And once it is done, we have an error case if the socket FD is not been created. Okay. So this is the first thing. Then we populate our sock adder structure. Okay. In this, we'll have the IP and the port for the socket in the listening mode. Okay, and here we are bind to that port. Okay, and we will be input here the socket FD which I have created here from the socket system call as a TCP FD. Okay, so here I am passing this structure which I have filled here. Okay, so now our socket FD will be listening to approximately 1024 connections in the queue. Okay, so this is a listening system call. So these are some of the basic system call for a server to work. Okay, so next, this is our main uh, functions which we are using. So first of all, whatever socket FD I got till now, after listen, I will be making that socket FD as non-blocking. So what do you mean by non-blocking is, for example, in the blocking call, we only accept one connection. So once client came, it accept the connection, it do some processing, and it come back and again start listening. But in the meanwhile, if any other connection comes in, it will be cancelled or fail, or we are sending errors from the server. But in case of non-blocking, the clients are not being lost when we are in the listening state. Okay. So earlier, in the client server TCP model, we are using select system call, and once we accept that connection, we will be firing to the respective threads for communication. But here we are not using any thread after we do accept. Rather, we are using a single libev loop to have a to have a watch on that FT which we are listening. Okay, so here if we go here, we have the non-blocking code, how to make this socket FT non-blocking. So let's go here and quickly see what is there. So if I quickly jump here, so they are taking socket FD here. Okay, I am getting the flag, whatever is there. So in this flag, and then we use fcntl call to make it non-blocking, and we are giving a flag o underscore non-blocking to make our socket FT non-blocking. Once this API is done, okay, so it will give 0 or -1. Depending on that, we will be going to the next call. And what is that next call? So we go back and next is a accept watcher. Okay, so all the processing on the socket FT file descriptor is done. Now we are ready to accept the connections from the client. And to accept that connection, we are using a accept watcher to listen to that clients. Okay, and we are passing this function. Okay, so this is defined here somewhere. Okay, so we are using the IO as accept watcher here, and we are input here. And here is the main API that will accept the connection from the client, and in the read only board. And if I go here, then we have this accept system call here. Okay, so we are input the file descriptor here. Okay, this sock adder and address len. So these are the common APIs we are using for TCP socket creation. Okay, now if the socket FD is less than 0, then there is a accept error on that. And then if it is a else case, we are again making this file descriptor as non-blocking, and we are printing accepting the clients. Okay, and the FD number. And here what I am doing is I have a client watcher as well. Okay, so we have multiple clients, and we are allocating the memory to each of the client whatever passed through this accept. Okay, so first time the first client came, it give you some FD. Okay, and after that it go to this else case and process everything. Okay, so here if you see, we have a client watcher here. Okay, and here we have sock client read. This is the callback that will be reading the file descriptor of the client that comes here after accept. Okay, and it is read only, and here we have this client read, and then we are putting this client watcher to the main loop. Okay, so earlier in the main loop, if I see here, we have the accept watcher. Okay, now I am putting one more watcher here in the main loop. Okay, so after this operation, we will be going here now. So what we are reading from the client. So this is what we are reading from the client file descriptor. So we are fetching 4K of data here. If read data is 0, this means client has not been connected. Okay. Let's just close the connection and we stop that watcher. We don't need that watcher now. Okay, so that client is gone now. So we will wait for the next client. Okay, so here we have code for stopping that watcher. Then we are closing this watcher and freeing this watcher like this. If it is less than, then we have some problem. Okay, nothing to read on something like this, and something not good here. I'm also stopping if this is less than 0. Okay, in the else case, when we go, if we have some read bytes, then what I will do here, I will write this echo command to the terminal, and I am whatever I read from that client, I will be printing through this write command to this FD, watcher FD. Okay, till now we have this socket accept client. Okay, we are accepting the connections one by one, and in this accept connection we have multiple watcher for each of the client. Okay, and we are putting this in the same loop, so we now have the single loop, that is the main loop that we are using, and we have different watchers over this. Okay, so that is not the case if we write our code with select system call or epoll system call manually. Okay. So what is the advantage of using libev? It is very neat and clean APIs. We can directly use it. The efficiency is very good and it's a production grade APIs. Okay. So we have nothing to worry about that. Just we have to care about the input and outputs in this API. And at last we have EV run that will run the loop forever. Okay. So after all these operations, whatever we have for accept and this client read, now we are ready with our server. Okay, so next is how to compile this server. So for that I just close this and gcc hyphen no, we have server and we have server.c. So I am getting some errors in ev APIs, and for that I need to link a library ev. And once I do this, it got compiled, and now I have the server app. Now I run server here. Nothing here. Okay. Now I go to the second terminal, and here what I will do. So in here we have 127.0.0.1 and what is that 8080. Okay. So we have NC. So what is this NC? ANSI is a command that we use for testing of the TCP and the UDP connection, making idle for network diagnostic. Okay, so how we test it? So first we'll check the server. Okay, so we'll do netstat hyphen nalp grep. What is our app name? Server. So if I do this, you see here you get a TCP socket running at 127.0.0.1 and 8000 port. Okay, so I will use NC now, NC hyphen V. Then we have this 127.0.0.1. This is IP and port is 8000. So once I do this, if you see here, connection to 127.0.0.8 is succeeded. So now I am able to connect to my server from the command line. Okay, so if I check on the server side, it will show accepted the client, this one, and the FD is also been printed. Now the next part here, if I take another terminal also and Here also, if I use nc-v 127.0.0.0.1 and 8000 is a port. So if you see here, sorry, nc, if you see here, this connection is also been succeeded. And if you see here, you get two connections now from two clients with FT number 5 and 6. Okay. So now this is an echo server. So whatever I type in the clients, it will be printed. So hello, I am client one. So you will see this prompt, and after that it's giving me the same output which I put here. Okay. And similarly, if you type here hello from client two, so it's also echoing here. So we have multiple clients that is connected to this server, and it's also responding as well. So we have not used any of the thread or anything for blocking this communication. So this is very highly efficient server. This is all about this video. If you have any query, just post me a comment. I will share this code in the description below. You can download from there. And also I will put the basic TCP server client communication video link in the description. So stay tuned with me. See you in the next video. Thanks.